this video, we will be discussing the Statistic 1 paper for May-June 2024, paper 5.3. Okay, so let's start with question number 1. Okay, so we have the number of the faces of a six-sided dice, 1, 2, 2, 3, 3, 3, and the random river X means the total score when the dice is rolled twice. So I roll the dice twice and I total the score together, then that is the value of X. So first, they want us to draw the probability distribution table for the X. Okay, so to decide the probability distribution table for the X, there are a few different methods that you can use here. Okay, the first one, you can consider possibility space diagram, because this one you throw the dice for two times, right? So it is still able for you to draw out the possibility space diagram in 2D. Okay, it's a table. Then they can show you all the outcome. So that's the first thing. And the second method is you might want to consider to list out all the possible cases. All right. Yeah, so it depends on you which one you want to use. So for me, I'm going to show you the possibility space diagram. It is because of, to me, right, although this is a bit time consuming, but you can see very clearly what are the results or what are the outcomes that we have. So first, I try to list out all the side. First, the number of the sides. So for one dice, I'm having the six-sided dice, right? It is a six sides. So I'm having all the number here, 1, 2, 2, then 3, 3, 3. So assume that this is the result that I get when I throw it for the first time. And after that, I also get the result when I throw it for the second time, which is using the same dice. So the result for second throw is still the same, 1, 2, 2, 3, 3, 3 as well. Okay, and now I need to list out all the possible outcome that I will get. So since they say that variable X is the total of the score when the dice is rolled twice, which means in this part of the table, I want to get the total for the two score. So as an example, if I'm having the first cell here, first cell means first throw you get a 1, second throw you get a 1, right? So the total score when you throw it twice, 1 plus 1 equals to 2. So same thing happens here for this particular cell. First throw you get a 1, second throw you get a 2. So you total the score up. So 1 plus 2 equals to 3, and so on. Okay, so when you try to list out all the possible outcome, then you can see all the numbers here will be the value of X. Okay, right. So this is what I should have. In the blue color one will be the value of the X, because I total up the score that I get when I throw the dice twice. Alright, then how can I get the probability for all the value of X? So if we observe all the blue color number here, the smallest number that we have is 2. So that means the probability for X equals to 2, you count how many 2 are there in our table. So there's only 1. So how many numbers do I have for all the blue color cell here? There are 36 numbers in total. 6 times 6, which is 36. So the probability of X equals to 2 is equals to 1 over 36. I got 1 out of the 36 cells, right? Then after that, for second number that I get, or I can observe, is X equals to 3. So again, I try to count how many numbers of 3 appear, okay, in the table. So you can see that it appears 4 times. Therefore, the probability will be 4 out of the 36 cells. So if you want, you can further simplify it, become 1 over 9. Same thing happened for the next one, which is X equals to 4. Okay, so you repeat the same process. So you count how many numbers are there, how many 4 are there from the table. So you can see that it is 10 over 36. Further simplify it, you will get 5 over 18. Then X equals to 5, Okay, so you count again, you are having 12 over 36, where you get also simplify, after simplify you get 1 over 3. Then x equals to 6 will be 9. 9 over 36, simplify become 1 over 4. Since they want us to express our answer in the probability distribution table, so let us create another table and show all the final answer. Okay, so I'm having the value of x. The first row we put in the value of x. The second row we'll put in the value of the probability for that particular x. So for x, I'm having 2. Then I have 3, 4, 5, and also 6. Then fill in all the probability that we already tried to find out just now. So equals to 2 is 1 over 36. 3 is 1 over 9. 4 is 5 over 18. 5 is 1 over 3. 6 is 1 over 4. Then to double check the final answer, you just try to add all of them together. Okay, so you add all the probability together and see whether is it equals to 1 or not. If it is equals to 1, then very likely your answer is correct. But if let's say when you total up all the probability, it is not equals to 1, that means something wrong with your answer. Then you have to double check again. Okay, right. Then for this question, I'm using possibility space diagram. Some of you might feel that it is very time consuming for us to set up the question. But to me, the biggest advantage for this technique is they show you every single outcome very clearly. That means there's no repeated outcome whatsoever. So you can see every single outcome very clearly. There's 36 outcome in total. Alright, then only from the outcome from the table, you group them according to the value of the x. Right, so another method is you can list out the outcome one by one, but please take note that you don't feel maybe you need to be very careful when you want to calculate some probability which is repeated. Right? So they are good and bad for every single method, so you can try to decide it by yourself. Okay, right, so this is what you have for part A. Let's have a look for part B. Okay, so for part B, they want you to find the value of variance x. So to find out the value for variance x, I need to get a few different things first. The first one, I need to use ex first. So ex means the summation of x multiplied with p. Second, I need to get the expected value for x squared, which is the summation of x squared multiplied with the p. Then only followed by the value of variance x, which is expected value of x squared minus the mean square. Okay, so generally I separate into 3 different steps here. Alright, so let us start. First step, first part, let us find out the expected value of x. So it is actually x multiplied with probability and we sum them up. So the idea is, the step is, you refer back to your probability table, distribution table. So you take the x2, multiply with the probability 1 over 36. So I'm having 2 multiply with 1 over 36, then plus the next x, which is 3, multiply with the probability 1 over 9. Then the next x again is 4, multiply with 5 over 18, and you add all the remaining cell by multiplying the x with the probability. Okay, then after that, just use the calculator to help a little bit, then to simplify the answer for expected value of x. So by right, you should be having 14 over 3. Alright, after that, we need to get ex squared. So for ex squared, expected value of x squared, I need to square the x first before I multiply with the probability. So same thing happen, 2 is the x, right? So I square it first, then only I multiply with the probability. So I'm referring here. Okay, I square the x, then multiply with the probability. Same thing happen for the remaining x, yeah? So 3, I have to square it, multiply with the probability, and so on. Okay, then if I try to simplify this answer by using calculator, I will be having 206 over 9. Okay, then lastly, only I try to find the variance. Okay, so to find the variance, this is the formula that we should use. Expected value of x squared minus the mean square. So expected value of x squared, 206 over 9, minus the mean square, which is 14 over 3, and we square it. Okay, then end up, the answer should be 10 over 9. Right, so this is how we get the value of the variance x. Alright, then we still have part C here. Okay, so let's continue to part C. For part C, they want us to find the probability that x is even, given that x is greater than 3. I need you to highlight the keyword given that. So this tells us that the question here is conditional probability. Right, so for the conditional probability, okay, if let's say find B given that A. So given that is a keyword, so when they want you to find B given that A, that means when you want to write a symbol, it should be B given that A. And then for the formula, it will be B intersect with A divided by the probability of A. Okay, so this is the concept on conditional probability. And now let's apply it to our question here. So they said x is even. Given that, so you put a slash, then x is greater than 3. Okay, so according to the formula, you should have x even intersect with x greater than 3 divided by x greater than 3. Okay, right, then let's have a look. What is the probability for x even intersect with x greater than 3? Then we need to go back to our probability distribution table. So x even and x greater than 3 happen at the same time. Means that this is the one when x is equals to 4. This 4 means greater than 3 at the same time is even. Then 6 is also fulfill the condition, right? Where x is even at the same time it is more than 3. So I need to consider the probability for these two number. Okay, these two x. So it will be 5 over 18 and also 1 over 4. Alright, so I'm having 5 over 18 plus 1 over 4. Then divided by, for the denominator, they are looking for x greater than 3. That means what is the probability that x more than 3? X more than 3 means that you should consider 4, x equals to 4, x equals to 5, and also x equals to 6. That means you have to consider all the 3 probability here. Okay, shouldn't include the 3 because there's no equal sign, right? So you should include the probability for 4, 5, and also 6. Right, so go back to our step here. So I'm having x equals to 4. This is a probability. Then for x equals to 5, it is 1 over 3. Then for x equals to 6, it is 1 over 4. Yeah, so just try to simplify this question, this fraction by using calculator. So by right, you should be having 19 over 31. So I keep my answer in the fraction form. So if you want, you can change it become 3 significant figure. Okay, so this is how we solve question number 1. Okay, so now we are at question number 2. Alright, so in a certain country, the height of adult population are normally distributed. So I think you need to highlight the keyword normally distributed with this mean and also the standard deviation. They want us to find the probability that an adult chosen at random will have height greater than 1.93. So I think it's very obvious, because you can see the keyword normal distributed. So x is normally distributed where x is the height of the adult. So mean provided is 1.64 and then the standard deviation is 0.25. But in the parameter, when we want to find the parameter for this bracket, it should be a square, right? It should be a variance, so you have to square it, which is a variance. 0.25 is standard deviation and you square it become a variance, right? Okay, then after that, they want us to find the probability that the x is greater than 1.93. So x the height more than 1.93. Okay, so because this is a normal distribution, so to find the probability, you have to change it become Z. That means you have to standardize it become Z. So how we standardize it? We are taking the number of X, the value of X, then minus the mean, minus 1.64, divided by standard deviation, so divided by 0.25. Okay, so try to get the value of Z. So value of Z that we get for this one is 1.16. Okay, then again, we should continue to use the normal table to find out the probability. Okay, but for the normal table, they only give us the value where Z smaller than a particular number. But we are looking for Z greater than. Therefore, we have to take 1 minus the value that we get from the table. So go to the normal distribution table, looking for 1.16. So where's your 1.1? Somewhere here, right? This is your 1.1, and then the 6 is here. Therefore, if you try to read the value, it should be 8770. Okay, so we go back to our solution here. I have to take 1 minus 0.8770. So use calculator to help us to simplify the answer. It should be 0.123. Okay, then let's have a look for part B. Part B. Okay, so there's in another country, then the height of the adult population also normal distributed. Yeah. So again, highlight the keyword. 33% of the adult has less than 1.56, 25% more than 1.86. They want us to find the mean and standard deviation of this distribution. Okay, so for this question, if you observe, right, they actually didn't provide us with the value of mean and also the standard deviation. Therefore, we have to use some information provided in the question to get the mean and also standard deviation. So first information is this one. 33% of the adult population have height less than 1.56. So if I try to translate this particular sentence into a symbol, it should be probability, the height less than 1.56 is equals to 33%. So I will convert into the probability, which is 0.33. Same thing happened here. This is a normal distribution. Therefore, to find the probability, I should change it become Z. So to standardize it become Z, I am taking 1.56, the value of X, minus the mean. But I don't know what is the value of mean now, so I just put it as a mu, divided by standard deviation. Again, I don't know the standard deviation, so I put it as sigma. Then equals to 0.33. Okay, then now if we try to draw a diagram related to this equation, Z smaller than a particular number and the area is a small area, which is 0.33. So that means the shaded area should be on the left and is a small area. Therefore, this particular value of Z should be a negative value because the center is a 0. So this Z is actually 1.56 minus mu divided by standard deviation. And at the same time, I want to find out from the table what is this particular value of Z. Okay, so you have to find out in the reverse way because now we have the information about the probability 0.33 and the large area should be 0.67. Okay, so we have the probability and we want to find out the value of Z. Just now in part number A is you have the value of Z, you want to find the probability. Okay, so you can try to compare the process here and you will realize that this is a reverse process. Okay, probability is provided and you want to find the Z. Therefore, you have to find out the probability. You look for the probability in the table. So the probability in the table is this part. All the Z is outside or on top. Okay, so if you have a look for all the value in the center, right, in the middle part here, is there any 0.33? I believe that you won't see it because the smallest value here provided is 0.5. Okay, so when you're having a small probability provided, instead of using this, we are using the opposite one. We are using the large area. So the large area here is 0.67. How I get 0.67? The total area under the graph is a 1. So I take 1 minus 0.33, then I get 0.67. So I don't use 0.33, I will use 0.67 here. Okay, so again, we go back to our table, looking for 0.67. So you can see this value here, 0.67, and try to read the value outwards, outside. So what do you get is 0.44. Okay, so that means the value of Z for this probability is 0.44. Okay, so first I write out my Z first. The Z that we want to have is this one. And I know that it is equals to 0.44. But according to this question, according to the diagram, you can see that my value of Z, excuse me, my value of Z is this one. Okay, which is should be a negative value because 0 is in the center. So the Z is on the left. Therefore, this value should be a negative value. Therefore, we should put a negative in front. Okay, then we try to form one equation from this equation that we have here. 1.56 minus the mu equals to negative 0.44 sigma. So mu is equals to 1.56 then plus 0.44 sigma. And this is my first equation. Okay, then now I need a second equation to get the another equation, a second information to get the second equation, so that I can get the value. I can solve the equation simultaneously to get the mu and also sigma. So what's the second information that is provided in the question? So the second information is this one. 25% of the adult have height greater than 1.86. So let's start. The probability of height more than 1.86 is equals to 25%. So I change it become probability, it should be 0.25. Okay, so the process will be the same like what we did just now. Right, so first we try to standardize it first. I'm having Z greater than 1.86. So we have to minus the mean. We don't know what is the mean. Divided by standard deviation, which is a sigma, then equals to 0.25. Okay, then again, we try to draw one graph or one diagram according to the equation that we have here. So normal graph is like this. Symmetry at the line equals to 0 in the center. Then 0.25 is a small area. Okay, and then the Z, they say greater than Z greater than this particular value is having a small area. So that means your Z, the particular value should be somewhere here, so that you will be having 0.25, a small area. Greater than means you shade the area on the right hand side. So this is the Z that we have, 1.86 minus the mu divided by standard deviation. So what is the value of Z for this part? You need to again find out from the normal distribution table. Reverse way, in the reverse way again. So you have the probability and you want to find the value of Z. Okay, so again, 0.25 is a small area. So I'm not going to look at 0.25, I'll look at 0.75. Okay, then go to the normal distribution table. For 0.75, if you aware, right, at the bottom part of this table, there's a shortcut table, I would say. Okay, then for the shortcut table, there are some certain probability. They directly give you the value of Z, which is more straightforward or more convenient. Okay, so you can have a look there. We are having the probability 0.75 and the value of Z is 0.674. So which is much more easier, okay? Instead of you need to find out the value here one by one and then you have to add the value up to 0.75. So they directly give you a simple shortcut, right? Okay, then continue further, 0.674, right? Okay, so I know that my Z is equals to 0.674. But before that, I need to decide my 0.674, is it positive value or negative value? So if you have a look for the table here, it is on the right hand side of 0. So it should be a positive value. Okay, then from here, I form the second equation, which is 1.86 minus 0.674 equals to mu. This is my second equation. Okay, so try to solve these two equations simultaneously. Then from there, you will be able to get the value of mu and also sigma. Okay, yeah. So let's try. I let equation number 1 equals to equation number 2. Okay, then by right you should have 1.114 sigma equals to 0.3. And then the sigma that I get here will be 150 over 557. Okay? Or of course, if you want, you can make it become 3 significant figure. But for the 3 significant figure, I will put it as the final answer later. Alright, so after you find the mu, you can find the mean. So to find the mean, I will strongly suggest you to use back the original fraction for the sigma. Okay, so I'm having 150 divided by 557. Okay, so this is to avoid the condition where if you put the simplified answer, yeah. Okay, when you substitute the simplified answer into an equation to find the mu, they might have chance that your final answer is not as accurate as the marking scheme. Right, so if you want to make sure that you get the perfect answer, then try to substitute the original value. Okay. Alright, so from here you get your mu, which is also a very long value. Okay, so for my final step here, I will just want to emphasize again my final answer correct to 3 significant figure, where the mu should be 1.68 and the sigma should be 0.269. Right, yeah, so this is how we solve question number 2. Okay, so now we are at question number 3. We were given some information about box A and also box B. So box A, 6 green ball, 3 yellow ball. Box B is 4 green and X yellow. So you can have a look for the process here. There's a ball chosen at random from box A, placed in box B. After that, another box is chosen from box B. So draw a tree diagram to represent this information, showing the probability on each of the branches. Okay, so for this question, you can see very clearly that basically we get 2 balls, right? The first ball is from A, then you put it into the B. After that, you take another ball, the second ball from the B. Alright, so we need to consider the first process first, which is you are taking out one ball from box A. When you want to take out a ball from box A, you might have green ball and also yellow ball, or also yellow ball. Okay, either one. Okay, so from box A, originally you're having 6 green and 3 yellow. Therefore, you should have 6 over 9. Okay, probability to get a green ball from box A, then 3 over 9 to get a yellow ball from box A. Right? Of course, you can simplify if you want. So 6 over 9, you can simplify, become 2 over 3. Then 3 over 9, you can simplify, become 1 over 3. Alright, then after that, we can proceed to box B. So for box B, we need to be extra careful because after you get one ball from box A, right, you place it into box B first before you get the second ball from box B. So the value will be a little bit different. Okay, so let's say now the first ball that I take is a green color ball from box A. I put it into box B. So now the box B is having 5 green color ball and also X yellow ball. So now what is the probability for me to get a green color ball from box B now? The total number of ball is 5 plus X. And the number of green color ball is 5. So I'm having 5 over 5 plus X. For the yellow color one, it will be X over 5 plus X. Okay, so this is the first condition that we have. If let's say the first ball that we take is green color, then this is a probability for us to get a ball from the box B. And now, if let's say the first ball that we get from box A is yellow color, so that means for the yellow color now, I'm having X plus 1 yellow ball in box B. The green color ball is still 4. So if you total them up, total, it is still equals to 4 plus x plus 1. The total is still 5 plus x. Okay, all right, so now I'm having green color ball in box B now. So to get the green color ball from the box B, probability will be 4 over the total 5 plus x. Then to get the yellow color ball from box B will be x plus 1 divided by 5 plus x. Because your yellow color ball now is x plus 1. Okay, yeah, so this is how our tree diagram look like. Yeah, right, so let's continue to part B. For part B, they said the probability of that both of the ball chosen are the same color is 8 over 15. They want us to find the value of x. Okay, so now we are given a number, information. So the probability of same color is equals to 8 over 15. Okay, so we have to look at our tree diagram just now. How to get the same color ball from both box. So there are two possible cases. The first one is first ball is green, second ball is also green. So to get the probability is you take 2 over 3 multiply with 5 over 5 plus x. Okay, so I'm having 2 over 3, 5 over 5 plus x. Then plus, I have another possible case where the two balls that I select is the same color. It is possible also that the both ball that I selected is yellow. Okay, so this is another pathway. This one also same color, right? Yellow and yellow. So to get the probability, it should be 1 over 3 multiply with this. Okay, so 1 over 3 multiply with 1 plus x divided by 5 plus x. Equals to 8 over 15. Okay, so what should we do now is we try to simplify this equation and get the value of x. We try to solve that. Okay, so to solve it, I will want to multiply the whole equation by 15 so that I can simplify. Okay, the denominator 15 here. Okay, so when I multiply the whole equation with 15, then I'm having this one, right? Multiply 15 into the first term here. So 15 divided by 3, you get a 5. 5 times 2, you get a 2. 5 times 2, you get a 10. 10 times 5, you get 50. So the first time I'm having 50 over 5 plus x. Okay, second term, 15 divided by 3, you get a 5, right? So you're having 5 multiplied with 1 plus x divided by 5 plus x. Then 8 over 15 multiplied with 15, you left only the 8. And again, now if I want to get rid of the denominator for 5 plus x, then I just multiply the whole equation by using 5 plus x. Okay, so from here, I'm having 50 plus 5, then 1 plus x equals to 8 multiplied with 5 plus 8x. Okay, so we try to expand everything and simplify the equation to get the value of x. Okay, so if you try to simplify a little bit further, by right you should have 3x equals to 15, and therefore you get the value of x, which is equals to 5. Okay, yeah, so this is how we solve question. Okay, so question number 4. The time taken in seconds by 15 members of 2 swimming clubs, penguins and dolphins, to swim 50 meters are shown in the following table. So we are having 50 members each clubs. Draw a back-to-back stem and leaf diagram to represent this information with penguin on the left-hand side. Okay, so let's start. So for recent years, right, when they ask us to draw a back-to-back stem plot, you need to make sure that you read the instruction of the question very carefully. Usually they will emphasize, okay, so which set of data need to put it on the left and then which set of data need to put it on the right. Okay, right, so this is my stem for a back-to-back stem plot. The smallest value is 35. The largest value is 72. So I should have my stamp from 3, start from 3, then 4, 5, 6, 7. Okay, then of course the left hand side should be penguins, my right, so Penguin. Okay, then the right hand side should be dolphins. Okay, then we can start to plug in all the value now, one by one, without doing any careless mistake. Okay, so the first number is 35, so you put a 5 here, then 9, 42, 44, 45, 45, 48, okay, and so on. So please make sure that you fill in all the value. Okay, then for dolphin, okay, so we successfully put in all the values here into the back-to-back stem and leaf diagram. And after that, don't forget about the key. Okay, so we should put in the key. Okay, so 2/4/1. So what's the meaning for 2/4/1 here? So it actually denotes 41 seconds. So we need to emphasize here, yeah, when you want to write the unit, or sorry, the key for the back-to-back stem plot or any stem and leaf diagram, the key must include the unit. Okay, so this one they measure the time using seconds. Okay, so don't forget about the seconds here. So the 41 is for dolphins. Dolphins on the right hand side. Okay, then 42 seconds for penguins. Okay, so this is basically how we get the back-to-back stem and leaf diagram for these two swimming club. Okay, then let's have a look for part B. For part B, they show us the diagram show a box and whisker plot representing the time for penguin. This is for penguins one, box and whisker. So on the same diagram, draw a box and whisker plot to represent the time for dolphins. Okay, so to draw the box and whisker plot, basically we need 5 important values here. We need minimum value, we need Q1, we need Q2, we need Q3, and also maximum. Where we need, okay, minimum, lower quartile, median, upper quartile, and also maximum. Okay, then of course, to get all this value, you have to refer back to your dolphin data. Okay, so in this set of data, right, they have tell us that we have 15 members for the club. So this is 15. No? Where's the median? Okay, median will be the center of the whole set of data. If I have 15 members, so that means the center one will be, I need to separate them into this combination 7, 1, 7. So 7 plus 1 plus 7 total is 15. And you can see that the center one will be actually the 8. This is the 8 value. Okay, so let's count the number 8 value from the smallest value. So 1, 2, 3, 4, 5, 6, 7, 8. So I think you should get this value right, where this is actually our median. Okay, so median is 51. Okay, so I go back here, median is 51. And let's look for the Q1 and Q3 now. So for Q1, it is the median of the first half of the data. So your first half of data is 7. You're having 7 value here. Then where's the median? Okay, so the median will be, I will separate into this combination 3, then 1, then 3. So 3 plus 3 plus 1 is a 7. Therefore, this is actually your Q1. Okay, so your Q1 should be the fourth number. 3 plus 1 is the fourth, right? So fourth number. So 1, 2, 3, 4. Your Q1 should be 48. So you just put it as 48. Then how about for this part? This is also the same. You separate it, become 3 and 1 and 3. So this is your Q3. So to calculate Q3, I calculate it from the back, where it is the fourth number from the back. So 1, 2, 3, 4. It will be 60. Okay, so I put a 60 here. Then now straight away read the minimum and maximum value from your data. So 36 is minimum, 71 is maximum. 36 and 71. Okay, so after I get all the value ready here, then you can just put in inside the graph paper. Okay, so let's plot the minimum value first. Okay, so minimum value is 36. So you can just put a 36 here. This is 36. This one, right? Okay, so I put a small line. And then 48. So where's the 48? Okay, so this is 48. Then 51. Then 60. And the maximum value is 71. So after you plot all the value here, what you need to do is like you just connect two horizontal line for Q1, Q2, and Q3. Okay, then after that you connect one horizontal line to touch the box from minimum value, and also another line from the maximum value, okay, to touch the box. So these two lines here we call them as whisker lah. So the center value here, the center box here will be the box. So that's why we call it as box and whisker plot, right? Okay, after you put in all the value here, don't forget to label. Okay, yeah, so this is how we actually draw the box and whisker plot. We need to find out these 5 values first. Alright, then let's proceed to part C. Part C, they ask us to state one difference between the distribution of the time for the penguin and also dolphin. So when we talk about the difference of the distribution, we are looking at some difference from, you can look at it from the box and whisker plot. Okay, so if you try to compare these two set of data, right, not a lot of difference, but I can see quite clear that for penguin group, the box is bigger or longer, and then for dolphin group, the box is basically slightly shorter lah, right? Penguin one is longer. So when you're having a longer box, right, that means it is widely spread. If you're having a shorter box or smaller box, basically we'll tell people that this belongs to a more consistent data or time. All right, so I think we can comment on this based on this one. All right, so let's continue. All right, so you can either tell them that the dolphins, or maybe you can tell them that the penguins, because penguins is more widely spread, right? So penguins time widely spread. Okay, so this is first way that you can write it out, or you can write in the other way, where you talk about dolphin, because just now I did tell you that dolphins are more consistent, right? So you can write dolphins time are more consistent, also can. They are basically having the same meaning. All right, so when you want to write out the difference, you can just write out any one of these two lah. Okay, then penguin. Okay, so this is how we solve question number 4. Okay, so now we are at question number 5. Salah decided to attempt a crossword puzzle in his newspaper each day. So every day he tried the crossword puzzle. So the probability that he will complete the puzzle on any given day will be 0.65, independent of other days. So find the probability that he complete the puzzle of the first time on the 5th day. So for this keyword first time, when we are having any question that is related to when the maybe the person who obtained the first success trial on any particular day or any particular time, the first success trial, so basically that belongs to geometric distribution. Alright, so here I know that I'm having geometric distribution with the probability of P 0.65, the single success trial probability lah. Then the first successful is on 5th day, so the number of days is equals to 5. That means the number of days to get the first success is equals to 5. So if that's the case, that means all the first 4 days are all failure. So 0.35 for the first day, 0.35 for the second day, 0.35 for the third day, and fourth. Therefore, usually we'll write as 0.35 power 4. Power r minus 1, which is 4, then multiply with 0.65. Okay? Then if you try to use calculator to help you, by right you should have 0.00975, correct to 3 significant figure. Okay, so for this particular question, it belongs to binomial distribution. Geometric distribution. Alright, so let's have a look for part B. Find the probability that Sarah complete the puzzle for the second time on 5th day. So now, the 5th day is the second success trial. So let's have a look here. 1, 2, 3, 4, 5. This is the 5th day, right? So it is a success trial. S means success. Or maybe X means complete. Maybe I put it as complete. But this is the second complete. That means in the first 4 days, should have another 1 complete day, right? So that means 1, 2, 3, 4, you have 3 failure and 1 complete, because the 5th day will be the second complete. Okay, so to answer this kind of question, it is basically a combination of binomial and geometric, where the first 4 days, 3 didn't complete and 1 complete, means that on any of the 4 days, right, on the 4 days, there's 1 day with the success trial. Okay, so this is actually binomial distribution, where you should be having 4, the n is 4, p is 0.65, okay, with only 1 success day. Then for 5th day, we calculate the probability separately. Therefore, to calculate the probability for this question, okay, first part, we consider the first 4 days first. I only have 1 success trial or 1 success day, okay, out of the 4. So it will be 4C1, 0.65 power 1, then 0.35 power 3. This is for the first 4 days. After that, I multiply the probability of the 5th day. So the 5th day confirmed will be the success trial, which is the day that complete puzzle. So completed puzzle will be 0.65. Okay, so again, this one is for the first 4 days. This one is for the 5th day. Then when you try to simplify them, by right you should have 0.0725, correct to 3 significant figure. Alright, yeah, then let's proceed to part C. For part C, now they want us to find the probability that Salah completes the puzzle for fewer than 5 times in 7 days. Okay, so for this kind of structure, right, if you can have a look, you are having a larger number, which is 7 days, then less than 5 days from the number, something happened. Something happened means this one is complete the puzzle. So this structure of the question belongs to binomial. So X is now binomial distributed. You're having 7 days is total. Then the single success trial is 0.65. That means the complete puzzle probability for one time is 0.65. Okay. Then now they want us to calculate the probability for X fewer than 5 times. So it should be less than 5. Right. So if I want to start from X equals to 0, right, it will be slightly longer. So I choose to take 1 minus. So when I take 1 minus, I have to minus X equals to 5, X equals to 6, and also X equals to 7. So let's start with X equals to 5 first. So your X equals to 5 is NCR, so 7C5, 0.65 power 5, 0.35 power 2. Okay, then minus X equals to 6, so 7C6. then minus again 7C7. Okay, so you cannot have x equals to 8 because the maximum days that we have currently is only 7 days, right? Yeah, so if you try to get answer, you should be having 1 minus 0 0.5322833242. It's a long value. Okay, then let's simplify into 3 significant figure answer. So 0 0.468. Alright, okay, then we still have one more part to go, part number D. Okay, so for part D, highlight the keyword approximation. Use a suitable approximation to find the probability that he completes the puzzle more than 50 times in the period of 84 days. Okay, so in AS stats 1, right, there's only one approximation that we need to consider where we are changing binomial become normal. Okay, so the keyword approximation is an important keyword, yeah. All right, so we are changing binomial become normal. So originally we are having binomial distribution where the n is 84. Then the probability of complete the puzzle is 0.65. Okay, so I want to change it become normal. To change it become normal, the first parameter in the bracket of normal is mean. Okay, so to get the mean, you take n, multiply with p. So n multiply with p, you get 54.6. Okay, so this one, just for your information, we get it by using n times p. This is the n, and this is the p. Okay, for variance, we are having np cubed because for binomial, calculate the mean is np, calculate the variance is np cubed, right? So here I need mean and also variance. Therefore, I'm using the formula for binomial because we are changing binomial to normal. Alright, so we still need to use back the original value from binomial here. Okay, so the variance will be n times p times cube, which is 19.11. Alright, and then they want us to calculate the probability of solve the puzzle more than means no equal sign, greater than 50 times. So we write 50. Okay, when you are changing binomial become normal, right? Because binomial is discrete random variable. And the normal is continuous random variable. Therefore, before you calculate the probability, you need to make some adjustment to the variable. So you need to apply continuity correction, right? So for continuity correction, x greater than 50, if you try to have a look generally, okay, so let's say this is binomial, we are having 48, 49, 50, 51, 52. Greater than 50 means that you start to calculate the probability from x equals to 51 and so on. And then to make the continuity correction, the line, the value that we use must be covered or must include the area or the probability that I want to find. So this will be my continuity correction value. It is between 50, it is between, I label it wrongly, right? So it should be between 50 to 51. Therefore, the value should be 50.5. Okay, so this is a small technique that we can use, right, to decide what is your continuity correction if you can't really remember, right? So x greater than 50.5. This is a continuity correction. Since we already changed become normal, right? So to calculate the probability, we should use the z. We have to use normal distribution table. Therefore, we have to standardize it become z. Okay, so minus the mean divided by standard deviation. Okay, 19.11 is variance. So I have to take square root of 19.11 to get the standard deviation. So please stay on this part. And after that, I will be having z greater than negative 0.938. Alright, then z greater than negative 0.938, this particular area will be same as z smaller than 0.938. Okay, then we try to find out the probability from the table, 0.938. Okay, so let's go to the normal table again, looking for 0.9. This one, 3 is here. So if I try to draw a line arrow inside, 0.93 is this value. And then 8. If looking for 8, right, you're having the value 20. So that means you should take the 20 adding to the last 2 digits in your original value. So 8238 plus 20, you are having 8258. Right? Okay, so this is 0.8258. Then again, I will want to correct it into 3 significant figure answer. So it will be 0.826. Okay, so this is how we solve question number. Okay, so the last question for this paper. Let's have a look for question number 6. How many different arrangement? Please highlight the keyword arrangement for the 9 letters in the word recorders. So let's have a look at what are the letters that we have. So in the word recorders, we are having 3R, 2E, then 1C, 1O, 1D, and also 1S. Okay, so these are the 9 letters that I have. So to arrange them, it will be 9, arrange 9 items, so should be 9 factorial. Okay, then divided by what? Divided by, you're having 3 identical R, you have to divide it by 3 factorial. You have 2 identical E, you also divide it by 2 factorial. So this is your number of arrangement for this question. Okay, so let's have a look for part B. They are asking how many different arrangement. Again, highlight the keyword arrangement one more time. The 9 letters in the word recorders are in which there's an E at the beginning, E at the end. The R are not all together. So since they already fixed the E as the first letter and also E as the last letter, okay, so you can see that in our letters here, E has been placed into a certain position. So there's no more E in our letters here. And for the remaining 7 letters in the center, I'm still having 3 R and also 4 other letters. Now they said the 3 R's are not all together. Highlight the keyword of not all together. So the meaning of not all together, right, basically is you assume that they are all together and the opposite meaning of it. So not all together means that the complement of all together. Remember that. Okay, so the opposite event of all together means not all together. Highlight this one. Okay, right. So when you are having something with not all together, what are we going to do is we need to me the easier way is you try to count the total arrangement first, then minus the case where all the 3 R's are together. Okay, then this is how we get the event or maybe the number of arrangement for not all together. Right, so I try to count the total first. Okay, so what's the total that I have? So total means that there's no restriction. So for the total arrangement without restriction, for these 7 letters in the center, I'm still having 3R and also 4 other letters. So there are total 7 items, so 7 factorial. Out of these 7 items, you are having 3 identical R, therefore you have to divide it by 3 factorial. And you get 840. Then now, I need to consider the case where all the R are together. So R are all together. I make them as one unit or one item. Then I still have 1C, 1O, 1D, 1S. So now you are having these 5 items here. 1, 2, 3, 4, 5. All the 5 items here are not identical. Therefore, when you arrange them, you'll be having 5 factorial. So it is 120. Okay, so to get the number arrangement where the R are not all together, we will take the total. Okay, so we'll get the total minus the event, okay, or the case where all the R are together. So you should be having this 720. Alright, yeah, then let's continue to part C. Okay, so for part C, the letters, 9 letters of the word recorders are divided into 2 groups. There are 5 letters and also the 4 letters. Find the probability, highlight the keyword probability, that the 3 R's are in the same group. Okay, so when you want to arrange something into different groups, the sequence is not important. Therefore, when you have the word divided into few groups or whatsoever, right, they actually give us a hint that this is a combination question, because you want to choose something and put it into maybe group 1 or group 2. Okay, so no matter you put it into group 1 first or you put it into group 2 first, the sequence is not important. Therefore, the concept should be combination part. Right, but when you want to calculate the probability for combination part, all the repeated letters we need to include in our calculation to get the correct probability. Alright, okay, so maybe we can try to list out all the possible cases first, yeah? Okay, so I'm having 5 letters group and also the 4 letters group. Okay, then for 5 letters group, right, there are a few cases. We focus on R first. So we focus on R. They say R are in the same group. So maybe we can have 3 R here. Okay, so again, let us recall again. The letter that we have is 3 R, 2 E, 1 C, 1 O, 1 D, 1 S, right? Okay, so if I put all the 3 R in the 5 letters group, then now let's have a look for the E one. Okay, so we put it into 3 groups. This is first group with the R, second group is all the identical E, third group is all the different letter. So after I put the 3 R in the same group, right? Okay, so now for 5 letters, for this group, there are a few possible cases for the E, for the group of E. The first one is, you can have 2E in the group of 5 letters. Then all the other 4 letters are in the 4 letters group. Second case is, all the R in the 5 letters group, but you have 1 E in 5 letters, 1 E in 4 letters. Okay, then another possible case is all the 3 R in the 5 letters group and both E in the 4 letters group. So these are the possible cases for us to have. If let's say my all the R is in the 5 letters group. Okay, then now I need to consider if for the cases if the R is in the 4 letters group. Okay, so if all my R is in the 4 letters group, there's one possibility where my E is here, another E is in the 5 letters group. Okay, then another result is all the R in the 4 letters group, E, both of the E is in the 5 letters group. So the place that I put all the dash here is basically all the other letters. Okay, alright, so we try to list out all the possible results first. Usually if you want to list out all the possible results, you need to be very careful, especially when you are having the identical letter in your group, in the selection. Okay, so you have to consider the identical letter one by one. Okay, all the possible cases one by one. Okay, so for this one, how can I write out the answer or get the number of combination for the first case here? So for this first case, all the 3 R are in the 5 letters group. That means for all the 3 R, you choose 3 of them and put it in the group of 5. All the E are in the 5 letters group. So for the 2 letters E, you choose all of them and put it in the 5 letters group. Then for 4 letters 4 letters, you choose all of them and put it in the 4 letters group. So the total number of combination is only a 1. Okay? Then for the second case, all the R in the 5 letter groups, so 3C3. 1E is in the 5 letters group, so 2C1. Okay, then one letter is in the 5 letters group, so from the 4 letters you want to choose one and put it in the 5 letters group. Alright, then the remaining E, just now 2C1, that means there are 2 E's, you choose one and put it in the 5 letters group already, so you left only one letter E. For this one letter E, you choose it and put it into the 4 letter group, so 1C1. Okay, then for the 4 letters just now, you already choose one letter and put it in the 5 letters group, right? So the remaining 3 letters will be all here, so it will be 3C3. Okay, so from here, if you try to compare it, right, I think you can see very clearly that all the 3C3, 1C1, 3C3 are all equals to 1. So if you want to skip this, no problem. Alright, because we are putting all the R always together, ma. Alright, so there should be no more 3C3 lah. But if you want to write it out to avoid confusion, also can. Right, so when you simplify this whole set of answer, you will be having the 8. Okay, so for me myself, right, when I write out the solution for this one, I basically don't write out all the 3C3, 1C1, 3C3, I just focus on this one. That means 2 letter E, I choose one and put it in the group number 5 letters. Okay, then the 4 letters, I choose one letter and put it into the group of 5 letters. The remaining one is always a 1 because you have to dump everything into the remaining group. Alright, so the combination is always a 1 for the remaining letters. Okay, alright, then same thing happened for the third case. So for the third case, so this one I don't write out, yeah? All the 3R means 3C3. For these 2 letters here, 4 letters, I choose any 2 and put them here. So it should be 4C2. Okay, both E in this group means 2C2. Then the remaining letters still have 2 letters, right? So the remaining 2 letters, you choose 2 and put them in the 4 letter group. So it also 2C2. So 3C3, 4C2, 2C2, 2C2. So and now my answer is only 4C2 lah. Okay, so 4C2 will be equals to 6. Right, so just continue the remaining cases in this way, then you will be able to get the answer. So 1E, I'm having 1E in this group, 5 letters group, so 2C1. You have 2E ma, right? Then you choose 1E and put them here. And after that, you're having 4 empty letters here, so it should be 4C4, all the 4 letters you put it here. Then 4 letters group, 3C3 for the R, 1C1 for the E. So for this case, you're having only 2C1, which is equals to 2. Okay, then after that, for part number 5, case number 5, this is 2C2 for the E. 3 empty letter here, you are using 4C3. Okay, then R, 3C3. The other letter is 1C1. So for CR here, you're having a 4. Okay, then what is the total number of combination? So you have to add all the possible cases here. 1 plus 8 plus 6 plus 2 plus 4. So the total is 21. So this is the total number of combination with the restriction given. Okay, then for us, we are calculating probability, right? So to calculate the probability, you should include the number of combination divided by the total combination without restriction. You're having 9 letters in total, and they want you to choose 5 letters out to put in the 5 letter group, then 4C4. Okay, so 9 originally is 9 letters. You want to choose 5 letters and put them in the 5 letters group. Then the remaining 4 letters, you want to choose them to put it in the 4 letters group. So it will be 9C5 times 4C4. So this is the total combination without restriction. So when you try to press calculator and help you to simplify the answer, by right, the answer that you get should be 1/6. Right? So this is how we solve question number 6, and here is the end of this paper. Right, so thank you very much for watching the video.